We are developing a direct teaching system using regrasp planning. In the system, a human demonstrates the usage of a tool by posing it in several key positions. The robot observes the demonstration, records the sequence of the key poses, and plans a pick-and-place motion to reorient and move the tool to the demonstrated goals. The initial pose of the tool could be arbitrary, as long as the robot can see it, reach it, and find a regrasp sequence. Both single arm and dual arm regrasp are considered in the planning. Also, we promote two modes for the robot to perceive the key poses of the tool. In the first mode, the robot may change its grasping configurations between the key poses. It may place down the object once and pick it up again to let the tool be exactly at a consecutive pose. In the second mode, the robot moves the tool with a single grasp. It is also the mode where the robot follows a trajectory. Essentially, the robot will interpolate key poses with a large difference using planning algorithms. In the video, the robot is working in the first mode. It moves the tool to the first pose, retracts, and moves it again to the second pose. The motion between the two key poses is connected by primitives and piecewise motion planning instead of continuous and smoothly interpolated motion. By simply telling the robot a sequence of key poses, it automatically generates manipulation motion without low-level specifications like how to grasp, how to move its joints, and when to place down the objects. At the Harada Lab in Osaka University, we are focusing on robotic manipulation problems. Our goal is to simplify the deployment of robots in future factories by leveraging cutting-edge technologies in motion planning and machine learning. The video here is an example of our simple teaching methods for fast redeployment.